Hello, in this video we will continue with part 2 on the topic on oligopoly and strategic behavior. We will learn the basics of the economics of cooperation. In other words, welcome to game theory. Here are the learning objectives for this part. I will introduce you to a situation that we economists refer to as a prisoner's dilemma. This game is adapted from a hypothetical but realistic case of two prisoners. Let's call these two prisoners Ali and Baba, who are thieves, and they have been caught by the police after committing a robbery. Before the robbery, Ali and Baba had made a promise to each other that if they get caught, they must keep quiet and not say anything to the police. So Ali and Baba are now caught, and they are brought in for interrogation in separate rooms. I think that you might have seen this kind of situation before in many police investigation dramas on the telly or in the movies. Well, if the thieves are convicted, they would be sent to jail. How long they would be imprisoned for depends on whether or not he confessed to the crime and on what the other thief is saying. In game theory, we often represent the choices that are available to the players in what's called a payoff matrix. The players in this particular game are the two thieves, Ali and Baba. So prisoner A is Ali and prisoner B is Baba. Now suppose that the police have only circumstantial evidence against Ali and Baba, and therefore they need the thieves to confess to their crime. So the police tells Ali that, Ali, you had better confess to the robbery. Whoever confesses first will get the lighter punishment. If you remain silent, and if your accomplice Baba confesses first, then Baba will get the shorter prison sentence and you will go to jail for a long time. The police tells Ali that they are giving the same options to Baba, who is in the other interrogation room. So Ali knows that Baba can either confess in order to avoid the prison sentence, or Baba can remain silent, just like their agreement before the robbery. So what do you think is going through Ali's mind? He is probably thinking, I wonder what Baba is doing. Is Baba keeping silent? Or is Baba confessing? So what do you think is going through Ali's mind? Ali does not know what Baba is confessing, whether Baba is confessing or not. What are the possible outcomes for Ali? Well, if both Ali and Baba confess, they will each go to jail for 5 years because they confessed. If Ali and Baba both remain silent, they would each go to jail for only 1 year because the police have only circumstantial evidence against them. If Ali remains silent, but Baba confesses, the stinking rat, then Ali goes to jail for 20 years and Baba will be set free. But if Ali confesses and Baba does not, then Ali goes free and poor Baba goes to jail for 20 years. So this is the payoff matrix. This particular example shows a 2x2 payoff matrix. 2x2 means that there are two players in this game and that there are two strategies per player. The two strategies in this case are confess and remain silent. Now you see here, this is a clearer picture of a 2x2 payoff matrix. See the box with the 4 quadrants? That's 2x2. Of course, there are other sizes that are possible for a payoff matrix. It depends on the games. Some games might have a 2x3 payoff matrix or a 3x3 payoff matrix, depending on the number of players in the game and the number of strategies. It is also possible that the players don't have the same strategies. that the strategies of one player is different from the strategies of the other player. Anyway, let's get back to Ali and Baba. The highlighted column represents what will happen if Baba confesses. From Ali's point of view, if Baba confesses, Ali will go to jail for 5 years if he also confesses, or Ali will go to jail for 20 years if he remains silent. Which strategy do you think Ali will choose? Yes, Ali will choose to confess because he wants to minimize the cost. By confessing, he goes to jail for only 5 years instead of 20 years. But what if Baba does not confess? Look at the payoffs if Baba remains silent. In this case, if Ali confesses, he gets to go free. If Ali remains silent, he goes to jail for 1 year. Which strategy do you think Ali will choose if Baba remains silent? Yes, to minimize the cost, Ali will confess. So, we see now that in this particular game, Ali will confess if Baba confesses, and Ali will confess if Baba remains silent. This means that Ali will confess regardless of whatever strategy Baba chooses. This tells us that Ali has a dominant strategy. Ali's dominant strategy is to confess. This means that he always chooses the same strategy no matter what Baba does. That's why this strategy is considered his dominant strategy, is dominant over the other strategy. Here is the definition of a dominant strategy. Now, Baba in the other interrogation room is probably wondering the same thing as Ali. Baba does not know whether Ali is confessing or not. What are the possible outcomes for Baba? Well, the highlighted row shows the possible outcomes if Ali confesses. So this is from the point of view of Baba, if Ali confesses. Look from Baba's point of view here. If Ali confesses, Baba will go to jail for 5 years if he confesses, or Baba will go to jail for 20 years if he remains silent. So to minimize his cost, Baba will confess. But what if Ali remains silent? If Ali remains silent, Baba goes free if he confesses, and Baba goes to jail for 1 year if he remains silent. Obviously, Baba is better off confessing. So, we see once again in this particular game that Baba also has a dominant strategy, which is to confess. Because Baba will confess regardless of what Ali chooses to do. So what will be the final outcome of this story, this game? Well, since both Ali and Baba have a dominant strategy to confess, the equilibrium outcome in this game is that they will both end up confessing. Therefore, they would both go to prison for 5 years each. An equilibrium in a game with strategies is called the Nash equilibrium, named after the famous mathematician John Nash. There is a movie about John Nash and how he came up with this theory, and the movie is called A Beautiful Mind. You might want to check that out. This slide shows the definition of a Nash equilibrium. In this particular example, the Nash equilibrium is also known as a dominant strategy equilibrium because both players choose their dominant strategies at the same time. Well, let me tell you now that some games don't have dominant strategies. It is also possible that some games, one player has a dominant strategy while the other player doesn't. There are also cases where the game does not have any Nash equilibrium. There are also cases where there can be more than one possible equilibrium. There are games where there are probabilities attached to each strategy. So there's such a variety. That's why game theory is a very big area of economic studies. It is very exciting, but also very challenging. So in this syllabus, you only need to know about the simplest game with a 2x2 payoff matrix. So don't panic. But we are not yet finished learning from our example with Ali and Baba. So what else is there? Well, you recall that the Nash equilibrium in this game happens to be a dominant strategy equilibrium. Ali and Baba both go to prison for 5 years. But is this the best outcome possible in this game? Isn't this a better outcome than confessing? If Ali and Baba both choose to remain silent, just like their agreement before the robbery, then each of them would go to jail for only 1 year instead of 5 years. Isn't that better? So why does this better outcome not happen? The answer is because there is an incentive for each player to cheat on the agreement. In other words, to renege. Let's see why there is an incentive to renege. This optimal outcome that I've circled requires both Ali and Baba to remain silent, but it's not sustainable because if Ali remains silent, Baba has an incentive to confess so that he can go free. If Baba confesses, then poor Ali is trapped with 20 years in prison. So Ali realizes that this possibility could happen, and therefore, to protect himself against this high cost, Ali has an incentive to confess in order to avoid the possibility of 20 years in jail. Ali has an incentive to renege on their agreement. What about Baba? Same as Ali. If he remains silent and Ali confesses, Baba will go to jail for 20 years. So Baba has an incentive to confess to avoid the possibility of a 20-year prison sentence. Baba has an incentive to renege as well, same as Ali. This is why the best outcome does not occur. This is the prisoner's dilemma. Each player does not trust the other player to keep to their agreement, and that's why the Nash equilibrium is not the best outcome. Are all games like this? No. If the equilibrium of the game happens to be the best outcome of the game, then there is no prisoner's dilemma. The equilibrium can change when the payoffs change. A prisoner's dilemma game illustrates why cooperation, like in a cartel, is difficult to maintain. The members of the cartel have an incentive to cheat. I will end this video here. See you in the next video when we apply game theory to examples involving business firms, not police and robbers. But the concept is similar. See you again soon.